biological habitat requirements kind of thing. So I think when you know that much about the plant, you can see very quickly why climate change would really set off some alarms with this. Botanically, wild rice is a annual aquatic grass. So the fact that it's an annual, I think it's one thing right there. I think it's more responsive maybe to climate change than certain other things that have much longer life cycles. And that annual nature really drives very much of the ecology of this plant. So its basic habitat preferences are well known. It grows in about a half a foot to 3 feet of water. Likes water that's not too acidic or too darkly stained. Water level fluctuations are an interesting thing. In any one year, you kind of don't like things to be too crazy. But actually, over time, you don't want things to be too stable. As an annual, it's kind of a weedy plant, and it needs some disturbance in the system once in a while. And if, for example, if you held water levels at the perfect height for wild rice and you kept them there for 20 years, you'd probably lose the bed, because the perennial vegetation will tend to outcompete it. And you need an occasional high water year or low water year or something to sort of set back the perennials. Grows best where you have this organic, mucky substrate. If you're in a canoe, you can probably drive your paddle at least a foot into the muck in most cases. You might be able to drive it right out of sight. The other thing that rice requires is gently flowing water. So you find it's the bright green material in these pictures. You find it on these river meanders, especially where the nutrients tend to settle out. And you find it on lakes like this. You can see there's the river coming in and out of there. If that was a landlocked lake, the rice would not persist. Kind of an interesting plant in this life cycle. Within that brief year that it grows, it's a submergent plant for a period, then it becomes a floating leaf plant, and then it becomes an emergent plant. So if you crunch all of this down, right now the plants are mostly past this floating leaf stage. That germination happens very early in the spring, right after ice out really. June is sort of floating leaf month. That's oftentimes considered a very critical time. As you get into July now, the plants are starting to become emergent. In a couple more weeks, they'll start flowering. And about the end of August is when the seeds are maturing. And if you're a rice harvester, it's about the end of August, early September. That's normally sort of the peak of the harvesting season. And again, this floating leaf stage is critical. The plant is not fully developed, but it's buoyant. The roots can still be fairly undeveloped. And so if you have high winds, high waves, it can pull the plant out of the sediment. It's actually, the plant also starts exchanging gases with the air column once it reaches the surface. And if it makes that change and you resubmerge it, you can actually drown it. Rice beds, because again, they're an annual, they look very different at different times of the growing season. So right after ice out, it needs a hard winter, a period of low oxygen conditions for that seed to break dormancy. But those seeds are actively growing already. That floating leaf stage in the upper right there, then the plants are starting to become emergent. I suspect that they're going to be a little further along than you see in the lower right here when you get out and look along the river. The river beds tend to mature a little faster than lake beds. And then on the lower left, you can see the beds kind of starting to brown up a little bit. That's approaching harvest season there. Also, because it's an annual, we see very different crops from year to year. And there's an old rule among rice pickers that in a 4-year period for most lakes, you can expect sort of a bumper crop and something near a failure and a couple of sort of in-between years. And that's just a natural part of the way this plant works. You can see pretty consistent production on rivers, but the more lake-like the site becomes, the more you see this kind of annual variation. And a lot of it probably has to do with nutrient cycling going on. I'd like to point out that this is a North American resource. There's 4 species in this family. Zizania is the family. One of them's found in Asia. There's one endangered one that shows up in like one site in Texas. There's 2 species in North America. One grows along the eastern seaboard and up to St. Lawrence. That one has a much smaller seed, and from a human harvesting perspective, it is less interesting, I guess. It's valuable to wildlife. But northern wild rice, Zizania palustris, right from the name, you know this is a plant that's evolved to live under northern hardy kind of or cold conditions. It needs a good winter oftentimes. Also like to point out that it has this fairly limited global distribution. We are the global stewards, I think, rightly, of Mahnomen, in northern Wisconsin, northern Minnesota, and parts of Canada. It doesn't quite capture all of its range, but the real area of abundance falls within this small scope. Rice has tremendous cultural value, and I do like to always touch on this at least. The Menominee Indians actually take their name from this plant, and the tribes that we work with here at the Commission, Ojibwe or Chippewa or Anishinaabe, have a tremendously close cultural relationship as well. And for those tribes, it goes back to the migration story and the fact that they were at one time living along the eastern seaboard, and certain prophets came to the tribes and indicated that if they were going to survive as a people, they had to undergo this western migration. And they weren't really sure where they were headed, how long this journey was going to take, but the prophecy was that they would be at their destination when they came to the place where the food grew on the water. So when they made it to this western Lake Superior region and stepped into the wild rice bowl of North America, those prophecies were fulfilled. And it makes us a religious motherland, really, to Anishinaabe people. Has tremendous ecological value as well, and you could do the whole lecture right on all of the different species that are found associated with rice. But just a few examples. The top left, we have black terns. This is a species not doing well in Wisconsin. I think the state just put them on their endangered species list. We find them fairly commonly associated with rice beds. Trumpeter swans have been extirpated, reestablished in the state. When I'm surveying rice beds, I'm picking up probably two-thirds to three-quarters of the state swan population. They're really keying in on these sites to nest and to raise their young. The top right, if that's a bird that's less common to you, to the Ojibwe, this was simply known as a rice bird. But that's a soar rail. Rice harvesters are familiar with this bird because they're constantly sort of skittering through the rice beds in the fall when they're harvesting. Traditionally, this bird was also harvested and consumed, and there's interesting descriptions of how delicious they taste after they've been feeding on rice in the fall. Muskrats love rice. They feed more on the green vegetation than on the seed. If they feed on those greens, they build their muskrat homes out of the straw. Then they also tend to create these openings in the rice beds, which are actually probably increase the utilization of the site by waterfowl. And ringneck is sort of my token duck here, but wild rice to a lot of people is probably best known for its value to waterfowl. And I would say that within rice's range, there's probably not another plant that's as important to ducks, especially during the fall migration, as wild rice. And then there's ecological benefits. It's growing in these shallow, mucky, nutrient-rich areas, and oftentimes in places where other plants can't really get a good foothold, but rice can. And those roots develop, they help hold the sediment together. Those roots don't decay very fast once they are developed, so they help even over into the next spring. They're holding sediments, it's breaking the wind action. So it helps you keep the nutrients down in the sediment instead of getting them stirred up into the water column where they can feed algae blooms and those kinds of things. That's a very cursory. There's loons love working around the edges, and herons and frogs and deer will feed on it, and insect populations of various kinds. So rice beds are just really biologically abundant in diverse places. So some of the concerns about climate change, and a lot of these I'd say are concerns. We don't have a great database of hard science to say we know this is a problem, but there's a whole lot of reasons you'd think that this is going to be a challenge for rice. Longer growing seasons. This plant does need a real winter, really, for those seeds to break germination. Burnett County in the western part of the state there is the heart of the greatest abundance of rice abundance in Wisconsin. You can see this is sort of a map of rice beds. We have the most rice where we have the most lakes. But growing season in Burnett County has increased almost 4 weeks in the last 60 years. That has got to be having a significant impact. And we're not seeing much rice further south in the state, and it may be that we're going to see sort of this migration of rice habitat to the north. Potential impacts from pest species. There's a variety of species that impact rice, but the biggest one over time is this. So that's a blow up of a rice seed on the right, and that's what ricers call a rice worm on the left. That's actually the larvae of a moth. That moth lays its eggs in the developing rice grain. It eats its way out, and then it starts going around and attacking other grains to grow. It may be that climate change is favoring the overwinter survival of this species and leading to higher populations in the rice beds. We're concerned about the impact, how climate change comes into this relationship with invasive species. Invasive species, of course, are problems all by themselves, but it seems like the milder the climate gets, the more, the better these invasive species tend to do. We've been sort of lucky that it's been harsh enough in Lake Superior and some of these areas that some invasive don't do very well. Well, the milder things get, the bigger concerns we're going to have. Two of the big invasives we're concerned about are curly leaf pondweed and Eurasian water milfoil. And these are problems in the lakes, and people want to deal with these problems, but then we also get concerned, are there going to be secondary impacts on the rice bed? If you go and you do a herbicide treatment in the spring to try to treat one of these things, what are you doing to those early germinating rice seeds? More frequent heavy rain events. This